Problem number 2708, maximum strength of a group. I want to talk more about the problem I have just done today. And previously I used DFS, a recursion, to finish this problem. And I used a state machine solution. Since it is having this definition, like the m min or max strength from nums 0 to nums I, and where at least k-scores should be selected. It is more like a state machine solution. And okay, so the thing that I want to optimize is that it has a whole bunch of if-else clause, and I think it's pretty ugly. So I want to optimize, and after optimization I found it can lead to the official solution. So I think it's really cool and I want to share more. So first of all, for this code, the first thing that I want to eliminate is the k, since k is only for to limit we had to select at least one score to the group. And I think I can optimize this. So and I asked Gemini, and it said this: for deleting k, I should add an option in every state to select itself. Like when m is 1 and nums I, the current value, is larger than 0, then this return value needs to add nums I. Like there are 3 options, whether to for m equals 1, we are now wanting to find a maximum, and since nums I now is larger than 0, so for finding maximum we would like to have previously finding maximum as well. And if we don't select nums I, there is not we don't do anything. And the other option is forget the previous stuff and start from ourselves. So we will add nums I, and for this nums I, it can replace the k, since at every step there is an option to choose ourselves. So so if we select nothing, it will not be the best answer. Okay, maybe if there is all of them are negatives, so then the default value will be important. If we don't select anything, then the default value is infinity, then it will not be worth it if we don't select anything. Okay, so let's first add nums I at the end of each state. And then we can delete k. And this should be, yeah, we can discuss this later. Okay, first of all, we find, oh, these two things are the same. Select max and no select max are the same. So the different thing for selecting or not select or no selecting is to multiply the current value. So let's leave two of the parameter and delete the repeated one. So we will delete this, and we will have the new parameter variable as mx for the max and mn for the min. So let's replace all this max and for min okay. And okay, let's check the boundary. So at first I want to try like if m equals 1, then it is finding maximum. So we will, and for I smaller than 0, it is invalid. So for this I will give it a negative infinity because it is finding max, and else I will give it infinity for finding minimum value. But then like running, when running, like it says it will be non value is not valid. So it's because for if it has 0, if 0 multiplied by negative inf or inf, it will be invalid. So and for invalid values it cannot compare with maximum and minimum. So we should change and change it to I equals 0, then it will return nums I. So for this we will definitely select one score and no need for k. So and then the next step to optimize is that when finding maximum, no matter nums I is larger to 0 or larger or smaller than 0, the thing that we need to compare is these it only like these answers return values are only five kinds. Yeah, like for this maximum part m equals 1, it has mx multiplied by current value and max itself and current value itself, and this has minimum value multiplied by current value, and this is still maximum value that is in itself. So yeah, there's no other things, so we can simplify it to max this and this. Okay, yeah, all of them are included. And when nums I is larger than 0, this option will definitely be smaller than this value. So yeah, it is reasonable, and if nums I is smaller than 0, like this value will be better than this previously maximum value. Okay, so this can be deleted, and for m equals 0, we can do the same thing. So return minimum, like we can check again, it only has mn multiplied by current value, mx multiplied by current value. Yeah, 4 options. Okay, then this can be deleted. Let's see how it runs. Okay, so far so good. Okay, then we can turn it into for loops, iterative method. So first of all, we'll have I and m as for the parameter. So we will name the matrix max strength. It will be equal to I'll first have maybe 1, and since m has only two situations, so we'll have multiplied by 2, and for in range n. Yeah, we don't use a dummy node since this boundary ends at 0, there is no smaller than 0 thing, so n will be fine. For the for loop, we will start it from 1, and yeah, like the default value will be itself, so max strength when I is 0, and no matter m is 0 or 1, we all will have non-zero. And for I in range 1 to n, we will have like max strength. yeah, we will write here. Copy this, and this will be maximum strength, and it will be I minus 1 with with m equals 1, and I minus 1 with m equals 0. Yeah, since I started from 1, this will not be out of bound. Okay, then we can copy it. Now, for max strength, so max strength I, the current state, if it is max, then this part copy, and for if m is 0, then min part like this. And for the test, our answer will be max strength n minus 1, since we don't have a dummy node, and m equals 1, since we want to have the maximum strength at the end. Okay, let's see how this runs. Okay, and for this we can optimize into an all-one space solution. So yeah, we will be eliminating the I, and before eliminating, yeah, so like we can have mx versus mn default for the default value for mn as num 0, and mx as num 0 as well. And yeah, we don't need this, and this will be like this. And since if we first do the calculation here, the mx will be the new one that we just calculate, so it should be written in the same line. And we will return max. Okay, let's see. Oh, we can delete this. Yeah, okay. So yeah, that is the whole optimization.